first. Yeah, okay, recording, and then start sharing screen again. Okay, so let's see. So we continue our discussion about that checkout lane simulation program. So in that, in this example, what we did is we have 10 queues created. So here we have 10 queue created. And the last class, we also discussed for queue from collection, because queue in the collection is an interface, is it? So whenever you want to have the instance of the queue, basically you call the linked list to create the linked list instance for the queue, but you only use a part of the linked list. That's you add that to the back and remove from the front. Okay, so that's the general idea here. And then we get some simulation parameters. What we collect is it like how long you want to simulate the arrival rate for the customer acceptance rate, something like that. And then we start to simulate. And when we start to simulate, is we start to tick off every single minute. Okay, so we simulate every single minute if the customer arrive. So if the customer arrive, then over here, what we said is if there is a customer arrive at this minute, then you are going to check out which lane is open. You start from the very first, and which lane is available, is it? And if the lane is available, then you are going to create a customer ID, customer arrival time, and the customer service time. So all of those information are regarding about the customer instance. And then you're going to add that customer object to the queue. So we are going to in-queue the customer to the specific queue. That's the first one available. So this is regarding the customer we take off, okay, every single minute. And at the same time, we are also going to service all of the lanes of the customer. So regarding that service lane method, so what over here is you're going to loop through all of the lanes, and then you're going to check if every single lane is front customer, as if there is a front customer. And if you have that front customer, then you need to serve the customer for that single minute. So that's why over here you just service minute you decrement. Okay, because our simulation is to tick off every single minute. So you decrement service minute by 1 for that customer, is it? And so you just also collect some information that we need to collect for our final report, is it? So that's why here you also need to collect minutes in line for every single customer, is it? And then you also to check if the customer's service time, if suppose the customer service time is 3 minutes you assigned when the customer first arrived, and here you already served. So this is the last minute for the customer, so you serve it. So the customer service time is going to be decrement to 0, is it? So you're going to remove this customer from the queue, is it? So basically here we call the linked list remove, but it's removed from front. So you deck. So basically here is we dequeue, is that we remove the front item. So we remove the front customer from this queue, okay? So that's the, when we do simulation, we need to simulate the customer arrive, then the customer service, is it? And we can collect the maximum time and total time, the information from you call of this 2 functions, okay? And they are updated. So when you finish your simulation time, suppose you said, okay, I want to simulate 90 minutes. Is it the 90 minutes you finish simulation? Then of the remaining time, what you're going to, of the remaining thing you need, because there, after you finish a simulation, not all of the customer finish their checkout. Is it? So if there are any there are any remaining customers, then you need to continue to service them to finish the whole simulation. So what the remaining part you're going to do is you are going to deal with all of the customers that's remaining in line, and we needed to services. So in this time, we needed to do the loop again. That within this loop, we are going to continue with basically every single minute. And then for each of the lane, you still need to do check if the of the lane already serviced. Is it? If not all of the lanes serviced, completed the service, then you just call that specific lane. Is it? You need to service the specific lane. And so you keep doing this, then you can finish of the remaining customers simulation in this program. So that's this part of finish out of the remaining, and then we are going to have the updated maximum time in line, total time in line. So that's the general part of the simulation. And the last part is to report your simulation result, is like the total number of customers, total time in line, and maximum time in line. So of those information you want to report. So this example, so basically discuss the a general idea about how do we deal with some simulation and you using Q. And this kind of simulation is quite common. It's basically a very introductory level of Q simulation research or application. So that's why here we brought it to you to try to understand how you can use Q to do a lot of simulations. Is it? You think about like for airport, is that you can also do simulations. Is it airplanes arrival and airplanes departure? Is it? So you can also use those, and a lot of other applications, because a lot of time you also need to do some simulation, do some model simulation. Then we kind of can have this approach. And what next I'm going to do is basically, let's see here. So the just going to try to summarize that that simulation program. Okay, so over here the idea is you have clock tick off. So you have every single minute. So we have single minute tick off to simulate. So that's the general idea. And then you have quite a number of queues, is it? So over here in our example is we have 10 queues. 10 queues, is it? And then what over here is with every single minute tick off, is it? And you just randomly generate a customer, generate a car, and then you check which queue, which checkout lane is the first available. Is it? So like starting from here, then this one is empty, is it? So you open it and the customer can come in, is it? And whenever the customer coming in, because this is simulation, is it? So the customer arrival time, you're going to record it, is it? And you're also going to randomly generate a service time associated with the customer, is it? And so it's keep doing like every single minute, and some customer going to be added to some available lane, is it? And then with the single minute tick off, so if you have some customer on this lane, and then you're going to also service, so serve the customer. Serve this customer. And serve the customer basically is what? It's you decrement that minute also. Is it to serve? And if this customer's time, the service time, already used up, is it? Then what we can do is you just take this customer off, okay? And at the same time, you're going to record the total time in line for the customer, is it? So that because later on we need to collect all of this information. So this is a general idea about this program. So I don't know if you guys have any questions about this simulation program. So do you have any questions? So any questions? If there is no question, we can move on to the next part. Can you see this new shared screen clear? Because on my end, for some reason, it's completely changed. So how about this part? Okay, so what next to do, we are going to do is we're going to have some leftover from Q, and we will try to finish it, okay? So more discussion about the applications. And over here, it shows another concept over here. It's called scroll, okay? So the scroll, so it's try to simulate the interactively, like what we did with computer. You can type something as it in. And over here, basically, as you try to input some integer to a variable, is it? So what we did is you type 1, 2, 3, 4, 5. Is it 1, 2, 3, 5 basically here? And then you say, oh, I type it wrong. I needed to remove 5 and retype 4, is it? So that it also knows. Then the variable will take 1, 2, 3, 4, is it? Will know that. So basically, how do we simulate this? Is that you can use a concept called scroll. Okay, so scroll is on one end you have Q, is it? So on the front end it's Q, is it? Because you always remove from the front end. But at the back, basically the concept here is stack, is it? So whenever you remove from wherever you remove, you can also remove at the back. Is it? So over here, you can also remove at the back. So it's not purely a queue concept here. So you combine the both of that in your application. So that's one of this. And then next, let's see, the next one. What over here is concept is called DAC. Okay, so DAC is double-ended queue, double-ended queue. So for a DAC is you can add, so you can do in queue, or we call it, sometimes we also call it like pushback. Is it pushback? And you can also remove, so that's the Q concept. You can also remove, is we call DQ. The DQ, there's another word generally term for it is, we call it pop front. Pop front, is it? So that's a general of Q concept. And the double-ended DAC, so this is called DAC. So what it is you can also add at the front. So add at the front, we can call it's kind of like you can call it a push front. So you can also add front, is it? And you can also remove from back, is it? Remove from back. So over here, it's you pop back. So for this kind of data structures, you can add and remove at both ends. Okay, so that's why we name it as double-ended queue. I remember maybe we have our lab. You need to design that data structure called a DAC using circular array. So you can think about it. If you want to use circular array, how do you create a DAC data structure? Okay, previously what we learned. And so this is DAC, and then let's see the other concept here. And over here, you can see in computing operating system, we also used a queue concept in various places. Okay, so in this diagram it shows, is it? So suppose like you collect some data from some disk, is it? And so you need to load it to memory and to some variable, is it? And then it needed to be processed by CPU, is it? And in case there are some other I/O interruption, then it needed to be dealt with another I/O operation, and then bring it back and for CPU processing. Is it? So how do we like to manage all of this tasks, make them coordinate together? Is it? So in this case, then over here, like you see, in the disk part, is it? We have a queue, we call it a resident queue, is it? Because it's a first in, first out, is it? And then if memory is available, is it? And then you're going to move your task, is it? To the memory part, is it? So over here, that has another queue, we call it a ready queue, is it? And over here, we also deal with, we follow the first in, first out, is it? And then if CPU is available, then you can get to the front task and be processed. But in case there is I/O interruption, is it? So the task then will be brought into another queue. So we call it a suspended queue, is it? But among the suspended queue, it also follows whoever first, is it? It's needed to be taken off from suspended queue whenever the ready queue is available, so that you can add it at the back of the ready queue. So with all of these queues arranged in the operating system, it can coordinate all of the tasks pretty well, and you know, so that you won't mess up the operating system's management. Is it? So this is another application regarding queue. And there is another concept in queue here is called priority queue. And then later on, when we learn collection, we are also going to learn the priority queue in Java collection library. And the priority queue different with our the queue that we already discussed is with each item, they are also assigned with priority. Okay, with priority. So it's not just a first in, first out in this case. So in this case, it's based on priority. So if a certain item assigned as a higher priority, even though that item coming in late, it will still be moved, it will still be placed in the queue to the front. Okay, so this is just a kind of like when you go to an airport, is it you take an airplane and the first class plus a comfort plus class, something like that. It's not like whoever comes first will take will be boarding first. So it's based on the priority. Okay, so. So this is another kind of queue, okay, but it still have general idea of the queue concept is first in, first out, because within the same priority. Is it so? If all of the items have the same priority, then in that case, we still follow first in, first out concept. Okay, so this is the another discussion about the queue application, and basically we finish the majority of the information about our queue. So I don't know if you have any other questions.